Whatever you say is, okay, we're live. Yay, welcome to DC404. Go for it, Lee.
My name is Lee Clemmer. I'm a managing consultant with IBM and their Cloud Identity Services group. I just got that job. I was very pleased after being a contractor there for 6 months, working with Federation Identity and Access Management. This presentation, however, is not sanctioned, approved, nor have anything to do with my job. I did it in my spare time because the group saw the first two and wanted to get more information about how we do Federation, usually for the enterprise. That's where my work is focused. In big organizations, at least 10, 50,000 people. One of the clients now has 9 million accounts there with IBM, and that's pretty impressive. That's the largest I've worked on. I've been in the Twitter and Facebook side of the world where you get larger than that. But 9 million for a corporate organization is a lot. So there's a lot of tuning that goes on with the directories, a lot of making sure we have scalability for that for the clients. And of course they want, with the work that I do, security for their identities, security connecting to various applications, and they want to have lots of, I guess, expertise behind it and not just throw it together like you might see. So hopefully we do a good job with Federation. We can get things very secure. A review, who knows what I'm talking about when I say Federation? Only 3 of you. He kind of does. Basically, we're talking about authentication partnerships between realms, domains, organizations, or just applications. I make a pitch in here that if you have one central identity store and authentication point to get into, you made it 2-factor or strong authentication, whatever type you prefer, you could use that in the other applications, whether they're Java, PHP, .NET, but you've got there, you can say, here's your authentication layer. You're dependent on the identity provider. We're going to send you a token. And so the strong authentication's happened over here. And you can tell your developers, look, just use this library, use this for your authentication. Don't try to build your own form piece or rely on something else. You've got a standard there for the protocol, within your organization. All your apps are going to use this protocol, which we'll talk about. As I said, the partners there use an identity provider. You can have more than one identity provider. And as we said, you can imagine there are lots of service providers. With things going out into the cloud these days, you'll find a lot more and more enterprises are putting certain functions out to the internet and calling it the cloud for their service providers like payroll, benefits, Salesforce, when you may have heard of it, is a big one. And lots of those, the sales side of the house features. Time cards and so forth, all has been outsourced to the cloud now. So you have some composite companies that make lots of those things together or standalone, some of the biggest ones. But they all use Federation with large enterprises so that you don't have to basically deal with the user having, if they've got 10 different apps, they don't have to have 10 different usernames and passwords. And they can use central organizations, usually Active Directory. They can use that same account and use that with their login. You can be sure they get in only with, say, their VPN and with a laptop or device that they're supposed to get in with on the network. You get a little extra layer of security there. So, as we said, you can have a partner within a federation be both an identity provider and a service provider. There's nothing stopping you from having a single application stack that uses the federation tokens to talk to an application on it. Usually, though, we do mean distributed between a provider like your corporation and lots of different applications out there. You see this in the internet world, which is not as big, with partnerships between the big players, the Facebooks, the Twitters of the world, Yahoo, and so forth. And you see another application out there, we'll use Federation, sometimes with SAML, but often with OAuth, OpenID Connect, to talk to each other so that you can basically log in. Especially with OAuth, you see log in with Twitter, log in with Facebook with your account. That Federation protocol is usually OAuth 2.0.
What was Microsoft using? They were one of the first ones to come out with that.
They've got a version of SAML used for a lot called WS Federation. It's, when you see stuff they've got out there, I can show you a URL that you hit and I know when I look at it, oh, the stuff in that query string in the URL, that's WS Fed. But it's similar to SAML, very close. You use SAML token format and then different stuff in the insertion. So we talked about that stuff already. As I said in the previous paragraph, this was made over the last 2 days, so some of the slides probably not in the most optimal order. So if I feel like I'm repeating myself or kind of going back, that's why I did this piece. And I thought I had an extra week because I thought next to last Friday or Saturday.
Yeah,
it's not the third one. I can it to be done by, oh wait. So
Surprise.
some of the code's not done like it was for previously. I can show you the whole thing. We'll talk about that. Basically, the idea there is we want a standard way of talking through these applications that are the target apps that are sharing that partnership. They're going to get a token. You're going to know. At least you've got that much security. You picked a standard. Between the partner, the IDP, and the SP, service provider, you do form that partnership. We mean you're not doing this on the fly. Like you decide, hey, I'm going to federate. I'm going to talk to your app. No, that's not the way it is. Usually I talk to the administrator on one side. My side, you can exchange information about how that gets created. You'd say, here's a certificate I got for signing, so no tokens came from me. And here's one for encryption. I'm going to encrypt something. Give me your certificate so I can use the public key to do it. Use your private key to decrypt it. And so you'll usually have one or more pairs of certificates there. They don't have to be like you would with SSL. We don't care so much that you check that cert signing chain back to a GoDaddy or someone. It's more, we want a series of asymmetric keys we can use. You can keep them private. SAML usually doesn't, but you're not looking necessarily for, hey, is this verified and signed that it's so-and-so. You care more about, I know I gave that to you, it's pinned or stapled in there, that's the one that's going to be on these tokens. I go in that some more detail as well.
It's kind of like going to a key signing party.
Yes, but using those partnerships you decide in there by exchanging metadata or typing in manually, I'm going to send you email addresses to identify the user, or I'm going to send you some other identifier. Those are set up, and a lot of times the applications need different things, and that's one of the advantages of federation within the token. For one application that keeps running, he might want an employee ID, and that's what he cares about. Sending him an email address means he'd have to go and extend the schema or add a column in his database or something. You're like, I don't have email addresses, I don't care about that. Somewhere else out there for an email application, of course, that is what they want, is a unique identifier for the user. And so when you create the partnership, one of the things you'll do is, what the heck am I going to send you to identify these people that's meaningful to you? As I mentioned, usually we don't use this for provisioning in real time, just-in-time provisioning. Usually it's always going to be, I've already decided with you what I'm going to send you in a token for parameters. I have seen some stuff out there for Salesforce and some other folks have lists of how people have done just-in-time provisioning for registration. And one of the customers I'm working with right now does in fact use federation in the token to say, hey, I'm here, I'm a guest user, but this person got authorized at this end, let them register, I don't really like that. But sometimes you have to.
It's kind of like ident on Unix systems. You're trusting that the guy on the other end is, actually screening people.
As I mentioned, I talked about it some here, the obvious benefit we get for enterprises they like to talk to us, hey, can you come set this up, is you can use them for a single sign-on. Somebody signs on at a portal or using Kerberos at their desk, and then they get a series of applications, whether it's email, anything off the portal. You can imagine enterprise apps. They just get to use one account with authentication at that central point, and they don't have to log in. The users love that. Right? But it's possible, but it's not forced on you. If you think, I want to implement the federation stuff, but I don't think single sign-on's cool, there is nothing making you, as a designer of your federation system and integrating it, to do that. You could tell them they need to re-auth when they hit something. You're just using a token at that target end. You could use step-up authentication. Hey, I see Keith's already been authenticated, but I wanted to put in some extra information, a PIN or something, but at least I'm going to say, yes, I think that's Keith in the token. Go ahead and give me some more. Multi-factor, we generally recommend that for the enterprise external portal. Use whatever you guys have for a token or some kind of messaging that goes back to the user for that. Don't rely on just a form, but they do. So we talked a little bit as I bounced around there about what protocols. I'm almost always talking about SAML 2.0 in these presentations because that's what people want to hear about from me. As we mentioned, Microsoft's got their favorite is WS Federation. They'll usually use a SAML token, but then have some slightly different pieces of the protocol when they exchange information between the IDP and SP. But it's really a matter of the protocol exchange and not so much the token. We had a presentation before on OAuth last time. Generally supposed to be an authorization protocol, not authentication, but we see it being used for authentication all over the place. That trust, I'm not convinced, is done well. And if someone using a secret that's just the user ID and password concatenated, it can be implemented very, very poorly. 1.1 is actually better, as I mentioned last time, than 2.0 for security. With with the signing that makes required in there. OpenID Connect was going to be, one of these times, going to go into it. The responsible people in the world that care about security a little more use OpenID Connect out there, and then maybe an OAuth token after that for the authorization. Google has some good information out there on that if you wanted to implement it. But that's not what today's presentation is about. Like Samuel, because it's better. We get with this token exchange, message integrity check. We can look at that signature and make sure we haven't changed any bits in the assertion. Validity, we can look at with a time window. That's part of the protocol. You've got to put some information in there about how long that token's good for. As an administrator or designer, you could make that window larger if you want or smaller. We're debugging. I'll crank it up so I get like 10 hours during the day so I can replay the same token. But you do have that as part of the protocol. Hey, it's not good before this time. Make sure your clock's synchronized. And it's not good after this time. Somebody can't grab it out of the ether and throw it back over there. As I said, it's verifiable. It came from the source. Not only do we make sure that its integrity is good, you know, hey, that's signed by somebody I traded Federation information with. That's one of my partners. I know. And it's encrypted. That's not a requirement of the protocol. I see often that's not done. People just trust the SSL wrapper is good enough using there. But more and more I'm seeing we recommend to people, hey, as long as you've got a couple certs and cert management in here, go ahead and put the encryption on. You really should. And we'll see in here that it's much nicer to know that, that's there. One of the advantages, again, I talked about a couple minutes ago, is you can send the least amount of information needed. Some of the solutions you've seen, you might send in a naive implementation of this with WS Federation on the box, it would throw a whole set of stuff. You just configured it blindly. The groups the users in, all these different attributes out of LDAP. New version doesn't do that, but that's not what you want. I don't want to send that to every partner. I want to send just a clock ID to you or a time system. I want to send just some other identifier, a login ID, Clemmer, out to some other app. And only needs the email address. So you, of course, don't send a password with the token, but you also don't have to send attributes that you don't need. Which means that if something did happen there and somebody grabbed it, if it wasn't encrypted, they see a little name identifier. All it says is maybe your email address in this case. That's not going to help you much. Sure, we don't want to give out little bits of information, dribs and drabs here and there to an attacker, but we're giving the least amount possible.
It's better operational security.
Yes.
The least amount of info possible.
Now, we talked before, SAML 2.0 limitations. You can get very complex schema set up. That XML standard that it uses lets you have an incredibly complex schema, and the definitions for setting up an XML schema. If the software wasn't there to do it for you, it would be an enormous pain. I don't see how people craft that stuff by hand. I had a customer that actually was dealing with this, trying to make metadata for this partnership by hand. I was like, let's just type in the values. This is nuts to to try to build that. And again, we call XML a standard, but as you guys know, if you've worked with it, the thing is, especially with Federation partnership, you can have a unique implementation for every single partnership and every single application and service. Say XML is a standard, you're just hoping somebody didn't do something weird in there, and your end can't deserialize it and make it into an object that's useful. You run into, again, very recently, a customer has something, there's a property in there for an XML element they keep sending. It's making one end of this partnership blow up and say, I don't like the sender. It's like, it looks fine. It looks fine here in the metadata. The token looks fine. It doesn't like something about that property on that XML element. And so you'd be better off if you just didn't care and just read the values out of the middle of the brackets. So one thing that is a concern is that as you get a larger web of Federation partnerships, you might have the same certificates on your end, but for every partnership you've got, they're going to have, from their end, one or more X509 certs, and they expire, right? And you got to have some way to manage them. And if the service at the other end or your partner isn't paying attention, for most software implementations, certs when it expires, your software turn off. Thank you, stuff. Enterprise organizations I've worked with, we never see a cert expire. So That actually comes up like the other larger issue. PKI infrastructure and good certificate management software in place because people just manage it. And they manage it, and then people leave management of that application, they go to another job, another organization. And somebody who's even got that responsibility, even they've got Verizon and a big, spreadsheet of servers, they just on that server. And again, they don't go looking like you might in SSL. Oh, look, I see the server. The browser says it in here, the user doesn't see it unless they were to look at that transaction with their keys. They're not going to know, And of course, as someone said last time, 2.0 is XML is kind of lame. So true. This whole presentation is because of you. Awesome. I'm glad you're here. So DC404 10D asked, is it only XML or does it support JSON? I said to him, no, it's only XML based. I said, ooh. And I said, So if I'm going to decide to go forward with this, I did this myself in my spare time. I converted SAML 2.0 from XML to JSON because of you. Awesome. I can put it in Node.js. It was a good, less learning curve than I thought, as we see with this. Again, the Java stuff is relatively new to me. The new job has me doing Java instead of C# or instead of doing nothing, which happens a lot with the design and architecture work for stuff. Sometimes I said, just go tell the developers, hey, we need this. And now it's like, hey, no one else is here to do that but you. Make that work. What would be involved? Well, we need to define properties here for identity providers, or IDPs, service providers, or SPs, user objects, tokens, and the messages. In SAML, the message is some type of token is called an assertion. So there's an XML protocol wrapper, and then inside that you've got some other XML that's called the assertion. It's got the guts of what we're doing. What to use? I just mentioned it because the slides are ahead of me, or I'm ahead of them rather. I wrote it in Java. I used for fun JSON files for the partner properties rather than putting it just in a database or something else. Properties for my other project was done in C#. I used the IIS web.config to hold most of it or all of it, and that's in XML format. It's very flat, but so that was a change. And I needed a library to talk my Java code to JSON. It's going to be easy for me because I'm not killing my most optimal, coolest thing ever. I want to get it to work. For you guys who don't know, JSON changed 40 to read and write. It's easy for machines to parse and generate. I'd say it's easier than XML and JavaScript. It is to have that look at it. Are you guys familiar? I'm telling you, look it up. That is so much easier. If you've got JavaScript code and you've got a JavaScript object, something you define in the code, you can dump it out. This stuff that's an amazingly better way to do it. A lot of the enterprise stuff I did again with .NET, everything they want it to be in XML because somebody decided that was the standard. It's brutal. If you have a problem with your XML library trying to make an object out of it and deserialize it. And I fought with some of those .NET libraries over and over that XML for the other project. Finding, again, the right ones, the right stuff on Stack Exchange or Stack Overflow. What am I doing wrong with my programming? It was murder, and it ought to be easy. And for some stuff it is. I don't doubt that much. Some things were very easy, but sometimes, as we mentioned, one complaint I really have about the decade-plus work I've done with SAML is that overkill. I mean, again, because of defining an XML schema you're going to use for the language and the protocol, there's so much stuff that you're expected to do. Once you know how to read it and what to look for, it's fine, but it can be overwhelming. And as I mentioned, if you've already shared the detail back and forth in the XML token, we don't need to repeat ourselves in every message. So much of the stuff, because of how you define the schema, gets into that XML message. All this cruft stuff. I'm like, I don't need you to send me the cert. I stored the cert in the app. I don't need you to send it again. I don't need you to tell me the format for this is email. We already decided it was easy, and it goes on and on. So, and when that metadata exchange I mentioned, basically the metadata format, you get an XML file that you can load into the server for Federation server. Like Microsoft's got ADFS for Federation server. You get the file from somebody you export one, and it sends you the file, and you get your little management interface for your Federation app, and it's like that. You don't have to type in, this is email format, this is this, here's the cert. And when it works, it's very easy. If I had Microsoft ADFS on both sides do that exchange, you can be up and running in 5 minutes. It's extremely simple. But when it doesn't work, I mean, you might as well not have it. It's pointless. Because trying to troubleshoot, okay, what's wrong with this properties and schema in this XML file, sometimes things just don't work. Microsoft will put in there for a certificate rollover, they'll put both certs, the old one and the new one, in there in the metadata when you export it. A lot of software on the receiving end doesn't like seeing two certs for the same thing. Reads the first one, crashes when it gets the second. That's a nice idea to do that. Say, hey, this cert's good till now, you can go ahead and have the next one. That's brilliant. Think about it, but everyone else you're partnering with had to know in your code to expect two. Okay, great. And yes, it's this bad. I don't know if you guys can see. That's XML metadata. This looks good, right? And here, and
It's the only thing you need.
I need a second monitor. So, what I'm doing, as you can tell from my griping about it, the JSON we're using is to be much tidier than the XML. A lot of that stuff is going away. And I think it's, as we said, far easier to read key value pairs using that style of syntax. I can't imagine if everyone hasn't switched to it for everything. It's just so much easier. The syntax conversion was surprisingly easy for me. And it was easier, as I just mentioned in my griping, coding than the XML.NET stuff. Some of that I probably mentioned, nobody would remember. Some of the work I needed to do to get stuff out of the token, I just didn't deserialize it, put it in an XML document or object. I just scanned for it, found it, and just loaded that into a string.
Oh, that's ugly.
It works so much better.
Speaking of how much better JSON is than XML, have you heard of JSON-X?
No.
It's a new format by IBM, which is basically JSON in XML format.
It's funny, if you go to the JSON.org site, they've got examples of how to convert XML to JSON, what it would look like in terms of your end-to-end encapsulation. Now, you don't, why? I don't
understand. IBM, because big corporation do what they want.
I work for IBM now.
Then then you're gonna find out. Somebody's gonna be like, "Can you turn this into like JSON-X or something?" And you'll be like,
"Nope."
So no.
The conversion for input and output from JSON to Java objects was really great. I found a great library with good documentation. So for the properties files I'm not showing you the XML version. Say, hey, this is my identity provider. I need a properties file out there to load up rather than loading out of the database I mentioned. So you see, syntax is very straightforward. I get a series of key value pairs with stuff. Is this guy a service provider? False. Is he an identity provider? Well, of course. This is something you see name ID format that's in there in the XML side in SAML. You want to know on both sides what that format is. You'll see things like unspecified. That doesn't mean I don't care what it is. I don't know. That's actually the thing that says, you can pick what you want, but that's unspecified means something. Or that's a type like email or opaque or persistent. You guys can decide what you're going to send. Identifier for a type. So usually when we aren't sure what you're sending, like a clock ID or something, you just pick unspecified. The others are weird and useful. I mentioned last time for name ID format, you can say transient, where that tag in the token gets changed every time you send one. Name ID attribute, we're going to pull that mail attribute. And then I said in here, in the assertion, you've got to send a user ID and that mail thing. So we wrote those for the service provider and the identity provider's properties in there. Now what do we need on the software side? Well, I need to take that stuff, load it in, and do something with it. So I need an object for the token, for the assertion, the user, when you get the user out of the directory database, And of course, that partner properties I just loaded. I've got to have some way to work with these things in memory to be able to make tokens usefully. Once we have all those objects, we can set and get pieces, fields, and out of the objects, then we can build a token. Go back to that one. You get the idea, I think. I know I'm blowing through this pretty fast of why you need all that. No, silence.
Yes.
That's the stuff we care about. How about that? And those JavaScript objects are great, but we're not writing it all in JavaScript. So as I said, we're writing the service in Java because I already wrote this in C#, it's SAML and XML, but the new job uses Java. Now, one of the cool things we needed here, Google actually has a library to convert JSON to Java objects called JSON, and that was amazing. Little, different ways to do it. That was so easy. It was like 3 lines of code, and you're done. I don't have to think about it. Platform, Linux, Apache, MySQL, and Tomcat. We have to have something to run and so on. There's a list of objects. The whole thing is just that stuff. A lot of it's things to get and set fields from, and there are only a few things that actually have methods that you call to do stuff. It's based on that Java servlet piece in Tomcat, so some of this stuff is just, wish it would work on the screen. And some of these things I just talked about. I need an assertion object, constants, some other stuff. Decrypt and encrypt, you can imagine. There's a service in there that actually receives information from the authentication piece, makes a token, and sends it out. But there's not much to it. This isn't like a massive crazy set of things. You got any properties in that, like I said, little Java code, all we need to do is set and get things like the identifier for the token, little unique ID in the token, who the issuer was, because we care about who's sending the token. That's a thing from SAML. The issuer is a unique identifier for me if I'm an identity provider. That's what that issuer name is. And I want to know status. It's a little piece of the code. User object, we got to be able to put that in the token. So we make a class for user, and then UID, mail, given name, and we're not going to send that this time, and a bunch of other stuff. And getters and setters to put stuff in the object when we make one. So we need that assertion. It goes inside the token and holds that user information. Same thing, we need to know what the signature algorithm is when we digitally sign it. Got to see what that name ID is going to be. We put in the token that's meaningful to SAML. The format, as we mentioned, whatever. That user get it from the other object. They already looked into lots of other stuff. And then it's a wrapper that contains the assertion object that we made. And maybe two different ways you could have it is encrypted to have it, so I can see it for encrypted type. It's meaningful to as I said, the JSON to Java object, unlike the other stuff, it's just little sections of code to kind of show you what I did. That's pretty much all it takes to get a JSON to stick things into that properties class. I mean, that's it. Get a little JSON piece, say, gonna make some JSON, make a JSON object, take our reader to read off the file, try to read it in, and then that sucker just pulls it into a properties object. And when I got to this point here and was done, I was like, wait, that can't be that easy. There's got to be lots of other stuff that happens after that.
So you just load it up with data.
It's pulling stuff out of a database for how that identity server is configured, all that stuff, loading it from metadata files, so let's put them in some JSON files.
That's pretty cool.
It's fast too. And for that stuff, I'm sitting there bouncing around talking about it. Some of those things, obviously, for each transaction, the object gets initialized and right, who the heck logged in? I need to make a new instance of that. These happen at init, the whole thing, not every time. You don't have to go in and read the properties again. I know when the server comes up, that stuff's going to be the same. So it gets initted. Like I said, the other way around, again, it's that easy. I'm going to take that object, I'm going to build some JSON, that thing to create it, and then for that response get writer for our servlet, that's just going to go out. You can go out to standard out to a file, and that print line just goes out for the servlet and prints it to the browser in the HTTP response. And there's that token object at the end. I mean, it's like nothing. It's nothing. Stuff I did on the .NET side was not that easy. Took a lot more code to get the same thing done. So, all together with that, we've got configuration information for how that server is going to work as a partner. We've got that pulled in. We got a way that to deserialize it was lazy. All the object definitions as Java classes. So we think we build tokens. In theory. Well, there's two. We need to make it all do some useful work. So we're also going to need that authentication interface. That first layer for authentication, whether it's forms login or whatever, that's what I did on this piece here with JSP. A module to take that login stuff from the form and actually do the authentication work. You know, hey, stuff the guy just typed in that post off the forum. Is there a user called Keith? Is he, you know, real? Did he put in the right password? All that. That's something you can't do just with the pieces I've got, right? Or a database looks like an you're going to have one that receives the request, which isn't finished. A service that generates a token, and then some of those helper classes to do stuff. So, but I had an extra week in the evening, so it's going to write the consumer, the piece that does a SAML request. It might work, but I'm not going to show you because it'd probably go like into a loop or trash. Or, it's not quite done.
Cause a black hole.
Now, where did my text go? That was going to be a beautiful visual description. Stupid PowerPoint of the pieces. Like as of the files back here, we got encrypt, decrypt, and sign. There's the service interface. But with just boxes, it's completely pointless. Look at that.
that is like
so meaningful with the arrows. I apologize. I looked through this whole thing at home, but on the Windows machine with the PowerPoint file not running on. It all look the same though. This is running off Google Docs. This does not look the same.
Well, Google Docs is not done until Microsoft won't run. That's the motto.
So, as I said, we've got classes in there with methods that are useful. That authentication class, the service one, and one called SSO that's supposed to be the consumer of SAML requests, or the core part of the application. The other stuff's all doesn't actually do things with methods that are meaningful. So that one's going to receive requests. That service generates tokens. Now, as I mentioned with SAML 2.0 and the previous version 1.1, you don't have to have the IDP necessarily receive a request, decode it, and do something. You can have it actually just generate a token for the user after they authenticate that they then go out and pass somewhere. That's called IDP-initiated single sign-on. Usually you want it the other way, where they get a valid request token from a known partner and generate one. The piece I have written is like IDP-initiated. You can just do a GET, like a REST call for, I logged in, make a token for me. Which again, considering we're using this technology with JSON, probably a REST interface makes more sense. A couple slides on that. So we've got encrypting, decrypting, and signing classes. I mean, they do the stuff you would expect. That was also easier than I thought. The stuff in C#.NET is not hard. Again, they make that very friendly and easy for you. And some of the stuff I've done in the past, years back with Java, looked like it was, more of a pain than it should have been. But it's really not that bad. For any of the stuff I needed for algorithms, there's a little encryption provider called Bouncy Castle. When you go in there and tell it, hey, I want to use Bouncy Castle for that stuff, there's so much information on how to get that to work on the net. You just look for like AES space Bouncy Castle in Google. You'll come up with a gazillion articles on how to do it. Like you said, the secret key spec thing, I didn't know was in there. That's kind of a cool piece. Look up secret key spec, Java, if you want to see how that thing works. It was way easier to get that working. You take your plain text that we've got here after we've taken it. That's just the JSON plain text we serialized. dump it in there. And as you guys probably, if you've done any of this web stuff, know, I don't want to just send the encrypted stuff out over the web in HTTP. It doesn't look pretty. We got a base 64 encoded. And again, it's not.
Does the standard require electronic code book?
No. So what I made, little ordinary forms login page. Look at that. It's pretty. Bootstrap is cool. I don't use Bootstrap. That's like
Web 2.0. Hashtag Web 2.0.
Look how pretty. And then a little interface just to get it working to see. Test it, manage. Way to log out so we can look at the tokens. That's it. This is 2 pages done. So what does it look like? Here is the JSON version, and it's not all pretty formatted because I wanted it to fit on the screen, and that's the way it gets spit out without spaces and line breaks. From our SAML token, a lot of you may not have been there, but we got that ID we generated that's unique for the token. We know that. It's in response to, hopefully you received a request ID there.
Kind of the equivalent of a sequence number.
The issuer, that's how you know, again, that's important. That's the identifier for that partner. That's you. Here's the issuer of this token, me, this little JSSO thing. You want in that part of it, status. This is all part of the protocol, by the way, in black, and then the assertion is inside in blue. See that? Status for that means whether the transaction was successful. I use that, basically in here. So you can see when it failed when you logged out, if it's encrypted. We want to know, so obviously an issue instance, self-explanatory, then our assertion statement. In here we say, what was that signature algorithm, our name ID attribute. Again, it's very important on the SAML 2.0 side. Want to know what we're looking for. As I mentioned, this is a good example. I've used the email attribute out here as name ID instead of it being down in the attribute statement portion of the assertion. You don't have to do that. It could be something that's opaque, tied with the user, but doesn't look like something to identify them. It can be transient, used just for one-time identifier. They can be, again, persistent and opaque. I could have it always be some one of those randomly created strings that use the same way every time. No one does that. They're usually, for higher security stuff, people use transient. It takes, you have to know that the other end's using that. You define that with your exchange, your metadata. It's less common. Almost always, what I'm trying to get at here as I'm rambling around is, for that name ID attribute, a lot of times we'll use email across the internet or another employee login ID like Clemmer because that's easiest. The other side can just look at that and go, if I need the extra information in the attribute statement, I can find it.
Given that you're doing IDP initiated stuff, is the in response to section going to be for most of the things that you do? Well, if you do IDP initiated, that should be fine, correct?
It generates a number, an ID, it doesn't leave it blank. You just generate one and fill it in like that. I just generated one randomly.
So
good question.
Even when it's IDP initiated, you'll just say it's in response to this thing that doesn't really
Right.
exist.
It didn't come from anywhere. It doesn't exist. But I made one.
Okay.
That way, if you did something with it, you could match it up in a log or whatever that, hey, I really did send the token.
And then the whole thing, you digitally signed it?
Yeah, we're getting there. So obviously you want the recipient in there. There's our time window, not before, not on or after. I want to know, hey, when did the guy authenticate? The audience, you can say, is a scope for not just that you're sending it to a recipient, but which domain they've got or which application. That's scoping piece for the audience. That's what that is. Context. I talked about this a good bit before with password. You could set in with your partnerships with people, I don't want them to be able to use just password. I want Kerberos, SP. They go, and I want them to use two-factor, or you can put different stuff in there and tell them, this isn't good enough for this particular app. Get out of the token and go, I appreciate you sent me a token, but you didn't log in the right way. Go get on the corporate network, on the domain, and log in. If you will, please. But they won't say that. It'll just say error and authentication. Contact your admin. That attribute statement inside, again, you've got those defined between you and your partner. What attributes am I going to send you? We've talked about that in some length. For this, we just said if you watch that we passed it, I said I'm going to send the UID and mail. That's what's in there. And then yes, with the certificates we've got, you're going to digitally sign the assertion, not the whole thing. So I make that assertion, stick it in there, and I've signed that part. So that's what those tokens look like. And it's astoundingly more compact than all the XML where you've repeated in brackets assertion and then close assertion. And audience, close brackets. The encrypted ones, as you can see here, have a little bit of different stuff in them. You can see which things we're hiding. This actually, I think, is a better explanation than when we looked at it in the original federation piece, because you can see. Some of the stuff's got to be there at the protocol level, so you know what the heck's going on. An ID in response to, status, did it actually work? When did it get sent? And of course, I want to know the destination I'm going to. Did this really, is it supposed to come here for me? But then we say encrypted assertion. After that, a bunch of stuff's hidden. We tell them the method, and hey, here's the key that we made for you.
So you can't pull any of the data out of that unless you've got the certs.
Right. I used the other side's public key certificate to make an encrypted key for them to use AES to symmetrically to pull all this data out. So, and those keys, I think for this one, the way it's set up now is I make a new one every time. So you grab the token and somehow manage to wrangle it apart by brute force. The next one we send will have a different shared key for that session. So there you go. After that, obviously, cipher data, that's the bulk of it. And then still we have the signature. Unwrap this, look at that assertion inside, and verify it didn't get changed. A little overkill. But that mirrors what you do in sample 2.0.
In the era of Snowden, I don't know that that's too much overkill.
And like I said, when I'm talking about it in Federation, people think, oh, that's not so good. Just as an authentication protocol, I think that's pretty thorough.
Well,
right?
you have non-repudiation.
That might be what you want.
Yeah.
That is pretty darn thorough. I mean,
And then it's all over SSL on top of it.
Yeah. Very difficult, again, when you're going with that to say, I don't think it came from the right person who signed it. So I don't, I think it's going to be tough with that. I haven't seen somebody hack it by brute force with this stuff in the tokens. Usually it's much easier. Get into the form, they had a weak spot in that front layer, that initial authentication. It's not worth it. There's too many other ways to get in.
Yeah. Crypto's like the last way you're going to get in.
So, and again, once you get in, all you're going to get is Keith's email address. You get a password or anything else useful. Hell, I already knew that. Let's see it in action. Let's see if I can get out of here. Escape. I had the incredible failure that I had last time. So, went there and hit. That redirect is still bad. Someone needs to show me in my Apache conf file how to get it to always send in.
Redirect.
I just set the Apache piece as a front end for Tomcat up yesterday, and I haven't done it in a while because there was no need. And Tomcat behind the proxy, I just set up SSL like that again yesterday just to. So
The thing is,
I wouldn't come here and show you guys that without it.
the thing is with redirects, unless you're using HSTS or whatever it is, you can't. You can do a man in the middle on it with a redirect, so it's better off not to do redirects.
I just mean for that piece when I hit it. I don't know why it went to port 80, but you came in on 443. There's nothing in there. All the stuff for the internal, hey, which page do you go to, is all off on the right-hand side. It ought to have stayed in SSL. I don't know what made it redirect to 80. We'll look at it later.
Yeah.
So anyway, try to hit that path just at the root. It says, I want to let you talk to this Java servlet instance with that JSSO path, and you're not authenticated, so hey, dude, give me some information. I think that's it. We put in a wrong password, so you can see that this isn't just fake. Incorrect username or password. No, I don't want to remember the password. Stop that. Hey, this is some of the stuff you just saw. Where's the never remember password? Thank you. I'll do it on my Windows machine at home. It's the first time it's on a little laptop.
Wait, Firefox IBM edition? Did IBM seriously build their own version of Firefox?
Grilled cheese with bacon.
Seriously?
This whole version of Linux that here, this open client, they gave me the laptop and said, you're working with customer data, it's proprietary, confidential, you get this Linux brick, you guys call it. And it's got their own stuff on it, their own version of Linux, they call it open client. What gets me is, okay, it's just far enough away from Red Hat or CentOS, and just far enough away from Ubuntu or anything. Like last time I was here, you remember I couldn't figure out what to do to get between the screens. There's just enough difference with that window manager. I'm sitting there flailing around. So now, what we said there is I've been authenticated. It's gotten at the database and pulled into my session here. We're going to look at the session ID. On the server side, it knows those attributes about the Clemmer. So it went through that authentication class and did stuff. But now, if I go over here to test it, it just makes me a little happy certain just like that. And because I didn't have the piece, that wouldn't do much for you. Normally, on the SAML side at this point, you'd have a redirect from that link that goes to an application, and there'd be some JavaScript that says, window refresh, go over here. But that lets you see that it works. That's the non-encrypted version. So there you go. Present. Shift F5.
No, this is pretty cool.
Nope. Where is it?
And it worked.
Control F5.
Password worked, by the way.
Password worked. You can use MySQL.
No, what you said.
Yeah, that's what I'm saying. I managed to put you in the database table correctly. One row modified. I hope that was the right one. Okay, so does that provide everything we want? We talked about a minute. I stopped from the original protocol. Did I get everything we wanted from sample 2.0 in my JSON implementation? Validity, limited scope, message integrity, message privacy, and extensibility, just like with SAML. We can put as much stuff in there as we want. With this, the same problem would arise as you'd imagine. Certificate management is still a problem.
Yeah, but that's not really an issue of the protocol.
No, I'm saying for implementation of it, to use it for SSO or for anything else. You're right, it's not the protocol's fault. It's just, this is one of the cases where you used Java key stores file to get it. 'Cause again, that's brain dead simple. It's what you would use, right? And those get scattered around everywhere in your enterprise on servers. And without certificate management to track which Java key store and what the password was to get the thing open and which password for the cert. Somebody post on that on the list. How do I get the certificate out of a key store file?
Might have.
I don't know. Brute force one of these. Yeah. And
yeah, you can't. Yeah, somebody did post that.
So there you go. As I said, right now it's just generating tokens, but doesn't redirect like you would. That's on the way. It's just almost done. As I said, I didn't add that JavaScript redirect. Maybe that's okay, because you could use this with a post the authentication interface and that servlet, and then just do a get to get the token, and then post that to whatever the service is.
They still have to pay attention to session management, all the other
usual. All the usual.
You go
stuff.
through all of this and leak your session cookies. You know, it's like, what's the point?
Time to drink.
And the current piece, state of it, the way I've got it done now, I've only got one partner, for instance. There's one file going to be there for the partner at the other side. Obviously, you only need your own properties file once, but I don't have a way in there to specify partner 1, partner 2, partner 3, whether it's with 3 files or 3 stanzas in a file. Just didn't get that far. The other pieces I mentioned I wrote in .NET, C#, you can put as many in there as you want, so you get sick of reading lines in a web.config file. And it would scale well. This obviously had to make another application instance in Tomcat just for the next partner would be painfully stupid because this doesn't take that much.
So no one else has actually tried this before?
Yeah.
Oh.
Not as well as this, actually. The web-based management piece I wrote, as you can tell, there's a thing there that says manage. I wanted to be able to edit the configuration files, like switch it to use encryption to show you. Again, didn't get that far with a 4L loop to pull the stuff in with some radio buttons and stuff. But so he thinks he's so clever. Not really. Surely someone else thought of something similar already. And yes, someone did. JSON web tokens. A little different, but compact URL safe means of representing claims, just like in SAML, between two parties, partners, just like in Federation. They're encoded as a JSON object, digitally signed using JSON web signature.
Is this an RFC?
And there you go. If you go out there, GWT, someone's got it. Theirs is a little different. This is small on the screen. It's got much less of the stuff. I don't, wouldn't say that it's the same really at all, but that's depends on how you look at it. But they've got a header that's got the algorithm, then the body that's got the claims in it, and then the signature at the end. That's what the colors are. They're just delimited by dots, periods, and basics before encoded. SAML implementation's better for a lot of the reasons we talked about, but someone still did it. This would be very fast for a Twitter or a Google or some people who, if you look up, probably thought that's such a compact, small, fast thing to do. You could probably handle a lot more than you can. I got references in the presentation if you want. For me rambling on too fast or not going in depth about something you want to know. We've got stuff on JSON, GSON, the servlet stuff from Oracle, which actually probably doesn't matter to you guys, but it's a good read if you want to see how those servers work and don't know. I didn't know much about it when I started the job. I hadn't done that much with the actual servlets back in Java. I was like, yeah, we can set up Tomcat or WebLogic or WebSphere. I didn't care about how the actual workings of, hey, let me pass a reference to this thing, spit it out, HTTP servlet. And it's interesting. There's stuff you can do that I didn't realize inside that. And I think it's easier. The handler I wrote for IIS, the DLL, that's a little funkier to get that to work in IIS. I mean, it's straightforward if you've done it before. But looking at it initially, I'm like, this seems clumsy. Let me look over here. Still seems clumsy. Oh, here's how to do it. And this was, hey, they all just work this way. This is the way it's supposed to be. And there's a SAML spec in there. If you really have insomnia, you can read the SAML spec, and that'll put you right out. Thank you. Have any pertinent questions?
Why would it seems like this is a lot of work as compared to like using OAuth 2.0. Why would I forget why. I know you went back. I know you went over this in the beginning. Went over this in your last in your last presentation. Why would I use something like SAML over like even this much less ridiculous SAML as compared to like OAuth?
Some of the stuff you see in there as part of the protocol and the token is rigidly defined to make sure that you don't get things like have them out of their validity time window. They've got to be signed. OAuth 2.0 it doesn't have to be signed. You can. 1.1 signature is part of the protocol. Just to answer the question, look at the last presentation and see there's so many reasons. I think the implementation, because it's not as rigidly defined, is sloppier, and we find things like the token someone's going to send over in OAuth. We've got people once they've registered, right, with that provider, provider's got an app ID and a secret, and you're over there with your login, generates a token, sends it here. It's the same token every time. And it's generated usually from you, like the Twitter one, the secret you used over there to get it, on their side, it's concatenation of your username and password. You remember that slide?
Yeah, that's fine.
I forgot that slide.
The implementations are sloppy because they didn't have the rigid part. Part of the protocol I'm complaining about is everybody got together as a big group and made decisions and made it ugly. The part that's good is some of these pieces are saying, you have to do this, you have to do that. OAuth 2.0 was we've all got to hurry around and get people connected so they can use these apps and buy stuff on the mobile phone, and I want to work with everybody, and it's very loosey-goosey. It's good if you actually used it just for the authorization piece and didn't try to have that be authentication of your system. Again, using those, if you got it behind OpenID Connect or something, the way some of the more serious players do it, it's fine. But then OpenID Connect isn't probably as easy to implement as that is. That's a good question.
OAuth 2.0 seems like a step backwards.
Big step backwards.
Do you remember when the guy who invented it just like flipped his shit and dropped that huge blog post right before he left?
Yes.
And he was like, OAuth 2.0 is like, he said, like the guy who invented OAuth 2.0 said that.
Yeah, I put that in the presentation for you guys. It's not just me complaining about OAuth 2.0. It's people who know far better than I do,
Like
more experience with it. Like the guy who wrote it. So that's that. If you have questions or want to see the code and stuff, I've got the code here. You can look at and go, my God, I can't believe you did it that way. What were you thinking? And some of the stuff I blew past that fast with code snippets that are just that big. If you want to see it, come over and we'll take a look at it.